Hello, welcome to the third lesson in geometry. Some of you have seen these lessons live, some of you have seen them virtually this whole time, but I'm hoping whatever method you've seen, you're understanding what's going on so far. So let's keep moving. What I need you to do is make sure you have your notes packet out and that you are on day 3, which in your packet, if you have one, is page 8. And we are going to learn more about the equations of lines. So quick opening exercises, write the equation of a line that passes through 4, 7 and negative 4, 9. Well, up to this point, what we really have, I'm sorry, there's stuff making noise off to the side. Up to this point, all you've really had is the y equals mx plus b form for a line. So if I said write the equation of a line passing through 4, 7 and negative 4, 9, you need to know the slope and you need to know the y-intercept. So if I want to find the slope, I can just find the slope between the points. So m is going to be delta y divided by delta x. And I'm going to do that using my head and say, well, from 7 to 9, my change in y is that it went up 2, and x went from 4 to negative 4, which is down 8. And 2 over negative 8 is the same as negative 1/4. So I have a slope of negative 1/4. So now I need to find the y-intercept. And I could do that a couple different ways, but one way that I haven't shown you yet, at least on video, is I haven't shown you how to find the y-intercept algebraically. So I'm going to do that right now. At this point, in the y equals mx plus b form of a line, I know that m is negative 1/4, and I know that x and y could be 4 and 7 or negative 4 and 9. And what you can do is algebraically solve for that y-intercept. So I'm going to use the 4 and the 7, just because they're both positive, and say y is 7, m is negative 1/4, x is 4, and I'm going to solve for b. Because I know if I'm going to write the equation of a line, the y and the x should really be the y and the x, the m should be the slope, and then the y-intercept is something I can solve for. So I'm going to do that. 7 equals negative 1 plus b, and then if I add 1 to both sides, I get b equals 8, which means the final equation of my line is going to be y equals negative 1/4 x plus 8. When you write the equation of a line, you don't put anything in for x and y. They have to stay there. The m and the b are what are getting replaced. That's kind of a lot of work, right? Like, there was a lot going on there. There's a better way. So, what essential information did we need to write the equation of a line? Well, before this, we needed the slope and we needed the y-intercept. And the form we wrote above is called, appropriately, the slope-intercept form, which is y equals mx plus b. But here's the thing, that's kind of like a handcuffing way to do the equation of a line. I need to have the slope and the y-intercept. Can't be any other point. It's got to be the y-intercept. You don't have the y-intercept that often. Or even more often, the y-intercept is some garbage number. And you don't want to have to like solve for that. So the better way is, why don't I use a point that maybe might not be the y-intercept, but it's a point I already know about? In walks what's called the point-slope form of a line. It is not essential to know the y-intercept to write the equation of a line. The following form allows you to write the equation if you know the slope, and I'm going to change this a, and any point on the line. Point-slope form is a way to write the equation of a line if you know any point on the line, any point, and the slope. That's all you need. Okay, yeah, you still need the slope because slope is really important, but now you can use any point you want. So the point-slope form of a line is y minus y1 equals mx minus x1, and then the three things that you're going to replace are these three numbers. M is going to get replaced with slope, and x1 and y1 are going to get replaced with any point on the line. It's very simple. Watch this. Write the equation of a line with a slope of 2, passing through the point negative 1, 5. So y minus y1 equals mx minus x1. I'm going to replace the m with the slope. There it is. My slope is 2. The regular x stays, and x1 is the x coordinate from your point. My x coordinate is -1. Y stays. Y1 is going to get replaced with the y value, which is 5. Minus, minus, that really becomes a plus. So this equation is y minus 5 equals 2 x plus 1. That's it. You're done. You can walk away. You don't have to get it in y equals form. You just write it down, maybe do some things with double negatives, and walk away. Here's how that's beneficial. Thing number 1, you might be thinking, well, yeah, but if it's in that form, how am I going to graph it? You graph it the same way you always did. Normally, when we graph things, we like plotted the y-intercept and then counted the slope. Now, instead of plotting the y-intercept, I'm going to plot the initial point and then use the slope. So my initial point is -1, 5. -1, 5 is right about there. And now I'm going to do the slope. Up 2 over 1, up 2 over 1. There's my line. It doesn't need to be in y equals form. One more thing I want to make sure that you notice. If you look at this final answer, okay, and you look at this point and that slope, notice the slope is a direct substitution. A 2 became a 2. But the point, which was -1, 5, is now a +1 and a -5. You negate the point when writing the equation. Okay, so when you write the equation of a line like this, you negate the point when plugging it in. All right, enough pontificating on my part. Let's do this quickly so you can see that it's really not that bad. I'm going to use pink. Write the equation of a line passing through the points 4, -3, and 5, 11. I don't care what else you do. If you're going to write the equation of a line, you always need to have the slope. Okay? Are there technically forms where you don't need the slope? Yeah, but nobody uses those. You need the slope. So I'm going to find the slope. So my slope, I'll use the y2 minus y1 version. If you want to do it in your head, you can do that as well. So y2 minus y1 over x2 minus x1. 11 minus -3 over 5 minus 4 is going to be 14 over 1. That's 14. So my slope is 14. And now I can pick either one of those points to write the point slope form of the line. I'm going to use 511 because it doesn't have any negatives in it. It's just what I decided to do. So I'm going to write y minus 11 equals 14 x minus 5. And there it is. That's the equation of the line. Walk away. Now, if you're thinking, wait, but Mrs. River, what if I decided to use the other point? That's okay too. It creates the same line, and I'm going to prove it. So let me go into my favorite friend, Desmos. Get my computer up. So I am going to go to Desmos graphing calculator, and you can always do this on your own calculator or in Desmos. I love Desmos. I don't like the calculator. So I'm going to go to Desmos, and the equation we had was y minus 11 equals 14x minus 5. And here's my line, and I'm just going to make sure that that does include our point, which was 511. Oh, look, perfect, there it is. And we had another point too. Let's make sure it passes through that one. 4, -3. It passes through that one too. All right, but you're thinking, wait, Mrs. River, what if I wrote it the other way? Well, remember, we have y minus y1 equals mx minus x1. That was our form, right? Well, what if I use the point 4, 3 instead of the point 5, 11? Well, 4 is going to go in for x1. M is still going to be 14, and y1 is -3. So that would make this +3. Look at that. It stayed the same. Okay. Okay. Now, what do I do if instead of just wanting the equation of a line, I want a line that does things, that's like parallel to things or perpendicular to things? No big deal. We just have to remember that when I have parallel lines, When lines are parallel, their slopes are equal. Who said that? It was me. I'm hoping, though, in your head, you were saying it too. Slopes of parallel lines are equal. So we're going to write some more equations. And I promise not to ramble on as much as I have been. Write the equation of a line passing through 2, 1, and parallel to 2x plus 6. To write the equation of a line, you always need the slope first. Well, if I want something to be parallel to this, that tells me that it needs the same slope as the other thing. The slope of this line is 2, which means the m we need is 2. And I want the line that passes through 2, 1, so the point we're going to use is 2, 1. Y minus y1 equals mx minus x1. Done. Write the equation of a line parallel to the y-axis passing through the point negative 2, 5. Okay, you know what? This one I'm going to sketch just to make sure we do it right. So I'm going to pass through negative 2, 5. And I want to be parallel to the y-axis. It's going to look like this. Oh, wait, no, that's not parallel to the y-axis. That's parallel to the x-axis. So let me fix that. Parallel to the y-axis, right? The y-axis is here. Parallel to the y-axis, right, would be this one. So if I'm parallel to the y-axis, I'm vertical. Vertical lines have x equals a number as their form because vertical lines have no slope. They have an undefined slope. So x equals a number. X equals negative 2. But Mrs. Vibber, I thought you said you always need a slope. I do always need a slope. But what if the slope doesn't exist? That means you have to have an x equals line. Write the equation of a line passing through this and parallel to that. Well, parallel things have equal slopes, so I need the slope of the line right there. Yeah, it's not in y equals form. Let us get it in y equals form. So 3x minus 2y equals 6. I'm going to solve for y, so I'm going to subtract 3x. I'm going to divide everybody by negative 2. 6 divided by negative 2 is negative 3. Negative 3 divided by negative 2 is positive 3/2. Now I know my slope. My slope is 3/2. And I'm passing through 3, negative 2. So my equation is going to be y minus y1, which is going to be y plus 2, equals m x minus x1. Ta-da! Mrs. Weber, I'm not convinced. Are those really going to be parallel? Desmos to the rescue. Let's just make sure. So if I bring up Desmos again, I'm going to clear this all out. And we want it to do what? We want it to pass through 3, negative 2. So there's my point. I want it to be parallel to 3x minus 2y equals 6. 3x minus 2y equals 6. Yes, Desmos can do non-y equals equation. Score. Okay, so I need to create a line that passes through this black point and is parallel to that red line. Let's see if ours works. Y plus 2 equals 3/2. X minus 3. Ta-da! It is. It works. We did it. As you go through and do your homework, feel free to pull Desmos up and check your answers because you'll know if your answers are right because you'll see it in front of your face. Write the equation of a line passing through negative 5, negative 1 and parallel to the x-axis. Okay, so x-axis, that's this one. So if I'm parallel to the x-axis and I pass through negative 5, negative 1, that's going to look like this. Oh yeah, those are horizontal lines. Horizontal lines are just y equals a number. And in this case, y equals negative 1. Look at that. We're done with the notes. So I rambled on a little bit. Make sure you know how to use Desmos. Make sure you know that if you want to write the equation of a line, you need a slope and you need a point, any point at all. And then when you write the equation using a slope and a point, you plug the slope in and you negate the point. Okay, some of my students like to remember that not only does the point get negated, but it kind of gets reversed because the y value comes before the x value when you write the equation. So if you want to remember like negate and reverse the order, you can. It's completely up to you. All right, stupid joke of the daytime. Let's see, what happens? How do you, oh, I know, we're going to do a series of jokes right now. How do you know if there is an elephant in your refrigerator? There are footprints in the butter. Terrible joke, but it's going to connect to the next one. So wait, and you'll see more. Everybody have a wonderful day.